I'm hoping it's recording this. We'll see. All right, so here we're learning about the ambiguous case. We have a triangle where the given angle is 41, the side across from it's 34, and the side adjacent is 48. This side is less than 48, so that means we have to find the height, because if this side was bigger than 48, we would know it would make exactly one triangle. But since it's less than 48, we have to see if this side will reach the opposite side. So we have to find the height. So I drew this perpendicular line here, and I'm going to do the sine of 41 is equal to h over 48 by using this right triangle right here to find this perpendicular length. So I'm going to cross multiply to find height, and that would be 48 times the sine of 41, and I get 31.49, which means that this side here is going to be long enough to reach the opposite side. Okay, so you can make one triangle, and if you were to like rotate this side like around this angle here, like swing this side around, you could actually make another triangle too. So when the height is less than the opposite side, but the opposite side is more than the adjacent side, that's when you can make two triangles. So now I'm going to draw out these two triangles separately. So this would be angle B because it's across from 48 degrees in this triangle. So we have this triangle, which I'll highlight in orange. But then you also have another triangle with a 41-degree angle, a 48-foot side, and a 34-foot side, because this side is also going to be 34 feet because it's the same side. So we'll call that B prime, just to show that it's different from this point, but it's still across from side B. And this would be C. So like this little side here would be C in the smaller triangle, and from A to B would be side C in the bigger triangle. So you have that triangle in orange highlighted, and you also have this triangle in yellow highlighted. So now I'm going to draw those triangles out separately. So I get triangle ACB prime. This angle is 41 degrees. This side is 48 feet. This side is 34 feet. And we also have this triangle, which also has a 41-degree angle, a side next to it that's 48 feet, and a side opposite that's 34. And this would be angle C, and this would be side B. So now we have to find both triangles. So to do that, we're going to do the law of sines. So if we look at this triangle for a second, all right, we could set up the law of sines by doing the sine of 41 degrees over the side across from it is equal to the sine of B divided by the side across from that. Okay, then I'm going to cross multiply. I'm going to do the sine of 41 times 48 on my calculator. And I actually did that earlier. I got 31.49 is equal to 34 times the sine of B. So to solve for the sine of B, I'm going to divide both sides by 34. So 31.4 divided by 34 is 0.926 is equal to the sine of B. So if I do the sine inverse of 0.926, that'll give me what angle B is. So on my calculator, I'll do the sine inverse of 0.926, because when you have the sine of a variable is equal to a ratio, the way to get that variable alone is to do the inverse, to switch X and Y. All right, so that comes out to be 67.8 degrees. So this angle here would be 67.8 degrees. And remember that when you do sine inverse, it's always going to give you an angle between 90 and negative 90. Which is why I told us the sine of 67.8 degrees. Now, there is actually, if I found the supplement, so if I make this little, there you go. Now, if I found the angle in quadrant 2 that had a 67.8 degree reference angle, which would be 112, and I did the sine of that, it would also equal 0.926, which is what we were solving here. All right, or like if we did the sine of this original angle, it would equal 0.926. So both of these angles satisfy this equation here. But when we do sine inverse, it's only going to give us the acute angle because that's how sine inverse is defined, or else it wouldn't be a function. Now, the reason I point out 112.2, which is the supplement to 67.8, is because that would be the angle B prime. So 112.2 degrees. So when you solve two triangles in the law of sines, in the bigger triangle, the one that's acute, that first angle that you find, the supplement to that angle is going to be the other angle B. And the reason why is if you look at this picture here, all right, we just found that this angle B here was 67.8 degrees. Then if you imagine like taking this side here and rotating it about point C, you would have that other triangle there. And if you like made this whole thing a circle, you could see that like CB prime and CB would be equal to each other. So both these are 34 feet long. So this is actually an isosceles triangle here in the middle of our picture. So if these legs are equal, these base angles will also be equal. And then the angle next to it is this one in this picture. I just took this yellow triangle and drew it alone right there. And now you get that adjacent angle. So when you have two triangles in the law of sines, which is only going to happen when you have an acute angle, the side opposite is less than the side adjacent, but the side opposite is more than the height, then that first angle that you find, the supplement to it will also be that angle. And now you could just finish solving these two triangles, you know, using the law of sines to find this side and subtracting these two angles from 180 to find these angles. So like angle C in this triangle would be 180 minus 41 minus 112.2 degrees. So if I type that in my calculator, I get that angle C is 26.8 degrees. And subtract these two from 180, 180 minus 41 minus 67.8. I get that this angle is 71.2 degrees. And then we can finish solving here. So this would be side C. We'll call it C prime because this we can also call side C. So to find C prime here, we could do the sine of 41 over 34 is equal to the sine of the angle that's across from the side we're trying to find, angle C, 26.8 degrees, over C prime, this side. Then we could cross multiply, so do 34 times the sine of 26.8. And that would equal the sine of 41 times C. So we could divide that by the sine of 41. And we get that side there, side C prime, would be 23.36 feet. So C would be 23.4 feet. So we got this angle C and this smaller triangle that's obtuse, and we got side C. And always do a common sense check, like 23.4 is less than these two sides, and it makes sense because it's across from this angle, which is less than these two angles. Now, when we solve for this side C, it should be bigger than 48 because it's across from the biggest angle in this triangle. So to solve for that side C, it'd be the sine of 71.2 degrees over C is equal to the sine of 41 divided by 34. And then for that, cross multiply, do 34 times the sine of 71.2 equals C times the sine of 41. So divide both sides by the sine of 41, and we get 49.05, which you can round up to 49.1 feet. And that makes sense because it would be the biggest side in this triangle, but not too much bigger than 48 because 67.8 isn't that much smaller than 71.2. All right, and now we just solved both possible triangles that have an angle that's 41 degrees. All right, a side across from that angle that's 34 degrees. And another side that's 48 feet. Right, this was 34 feet, not 34 degrees. So notice how there are two possible triangles that have that. And that's why ASS is called the ambiguous case, because it's not clear that there's one specific triangle. Once you know there's two triangles, then that first angle that you find is going to be equal to this angle. And then that's going to be supplementary to the other angle B in the other triangle because of this isosceles triangle here. And also because, like we talked about, whether you were solving for angle B or angle B prime, you would do the sine of 41 over 34, right? The sine of 41 over 34 equals the sine of B over the side across from it, 48. And that's what we did here. And then when we solved for the sine of B, the calculator told us it was 67.8, but because sine is also positive in quadrant 2, there's also that other angle that's supplementary to it that would also satisfy this equation here. So that's why you get two possible answers, but the calculator is only going to tell you one because it wants sine to be a function. All right. So I will also take a picture of this and I'll put it on Classroom. So if you don't want to watch that whole video again, you could just kind of use this and follow along. All right, but let's go to number 2. If number 2 is one or no triangles, this will take a lot less time. And I see that number 2 is an obtuse angle that we're given. So I know that when it's an obtuse given angle, there can only be one triangle or no triangles. All right, so I'm going to draw this picture. And I'll do it the same way every time. I'll put my side that I don't know across the bottom of the page. And now I'll make this angle 126.5 degrees. That would be angle A. All right, which means that this would be side A. This would be 25.5 centimeters. Because if this did make a triangle, that would be the side across from it. And this side is 51.9. So that'd be side B. This would be side A. Now, if you look, all right, this side is shorter than that side. So if you were to like try to rotate it around this point here to try to reach this side, it wouldn't, because it's this point, like the shortest distance from this point to this side would be 51.9, like on a straight line. So this side has to be bigger than 51.9 in order to reach and make one obtuse triangle. But it's not, so number 2 would be no triangles. So that's nice when you get no triangles. There's no extra work you gotta do. So let's try number 3. Number 3 says we're given that angle C is 27 degrees. You know what, I'm gonna do this on a separate sheet of paper because I have a feeling it's gonna be more than one triangle. All right, so we get that angle C is 27 degrees. Side C is 330 meters. and side B is 404 meters. So when I draw that picture, I'm going to draw it with the side that I don't know. So this would be side A, because I know C and B, parallel to the bottom of the page. I'm going to put the given angle here, make that 27 degrees, and I'm drawing it to look acute because 27 degrees is acute. All right, I'm going to make this side 330 meters because that would be side C across from that angle. And side B I'll put here because I know the length of it and it's not across from angle C. So that could be side B. Now, if this side opposite the given angle was more than this side, right, then it would reach this side without a problem and it would only make one triangle. But this side is less than that side, which means we don't know if this side will reach. The only way to tell is to take this angle, which would be angle A, and see the shortest distance from that angle to the side. See, is it more than 330 or less than 330? So we're finding the height. So we'll call that H. And I'll say the sine of 27 degrees is equal to H over 404. So then I'll do that on my calculator. I'll multiply the sine of 27 times 404, and I get 183.4. So the height is equal to 183.4 meters. So that means we're going to have two triangles. All right, one of them is going to reach there and create triangle ABC, where it looks like this, where C is 27 degrees, side B is 404, and side C is 330. And this angle here is going to be acute. Or this side AB, if you imagine like swinging it around angle A, it could also make another triangle like this that also has an angle that's 27 degrees, an adjacent side 404, and an opposite side 330. All right, and we'll call this B prime because it's angle B because it's across from 404, but it's different from this angle B. So I distinguish it with that little tick mark there. So now I'm going to draw the triangles out separately. So I have this triangle, CAB. It'll look like this. Okay, and then we also have this other triangle, CAB prime, that will look like this. All right, so when you have the ambiguous case with two triangles, one is always going to be acute and one is always going to be obtuse. Now I'm going to call this A prime because it sort of corresponds to this angle in this picture, but it's going to be different than this angle. And I'm going to call this B prime for the same reason. And I'm going to call this C prime for A prime, that lowercase a prime, for the same reason. Because this would be lowercase a. It's different from that length. This is going to be longer, but they both are like in the same position in both triangles. All right, so now let's find angle B because that's the only one I could find right now with the given information. I could do the law of sines. The sine of 27 degrees over 303 is equal to the sine of angle B over side B. Now I know when I do it this way that I'm going to get this angle B because it's acute. And I know that when I have to do the sine inverse of any ratio, it's only going to give me angles that are between 90 and negative 90. So as long as it's sine of B equals a positive number, meaning quadrant 1 sine is positive, I'll get that acute angle. All right, and then I put B here. I should have put 404 because I know what that is. So I'm going to fix that. So now I'm going to cross multiply. I'm going to do the sine of 27 times 404, which I have already. That's going to equal the sine of B times 303. Because it's across, like for the law of sines, you do the sine of an angle divided by the side across from it. So the angle across from 27 is 303. And then the reason why it's sine of B over 404 is because the side across from angle B is 404. All right, good question. So when I cross multiply this and get the sine of B alone, I get the sine of B is equal to 0.605. Which means B is equal to the sine inverse of 0.605, which it should not be a surprise that when I type that into the calculator, I get an acute angle because sine inverse can only equal angles in quadrants 1 and 4. And it's not going to be in quadrant 4 because 0.605 is positive. So I get 37 degrees. And I'll round that to 37.2. So in this picture, I just figured out that this angle was 37.2 degrees, which means in this picture, this angle here is going to be 37.2 degrees. And in this picture, AB prime and AB are the same length because it's the same side. I just rotated around this way. And you can see here, that's also 303. So this is an isosceles triangle here. So this base angle has to equal this base angle. So both base angles will be 37.2 degrees. And then I can get that this angle here is going to be supplementary to that because they form a linear pair. So this angle is going to be 180 minus 37.2 degrees, which is 142.8, which means this angle in this picture, the obtuse triangle, is going to be 142.8 degrees. And now I could just finish solving them using the law of sines. But just to point something out here that I pointed out earlier, if you were ignoring this triangle here and just trying to solve this one first, you would set it up the same exact way as you would right here. You would say the sine of B over the side across from B is equal to the sine of C, 27, divided by the side across from C, 303. Then when you cross multiplied, you would get down to here, and we got 37.2 because the sine of 37.2 is equal to 0.605. But the sine of 142.8 is also equal to 0.605 because both these angles have a reference angle of 37.2. So this will equal either positive or negative 0.605. And they're both in positive sine quadrants, so they'll both be positive. So now we have to finish solving both triangles. Oh, how did C become? Oh, I see what you're saying, 303. That's just me being dyslexic. It should be 330. All right, my fault. I just wrote it down wrong. So, oops. So here, I'm just going to change the question so I don't have to change my work. So that's just a mistake. My bad. I didn't get what you were saying when you said that. Why is it 303? So it should have not changed to 303. I just made a mistake. But let's pretend it was 303 to begin with. Nothing would really change about this other than, you know, if this was 303, then these angles would change a little bit. But just to save time, instead of doing this all over again, I'm just going to change the question to 303. All right, and then now Now we can finish solving. We could get that this angle here, we could find angle A by subtracting 27 and 37.2 from 180. So 180 minus 27 minus 37.2 gives us this angle here is 115.8 degrees. And this angle here is going to be 180 minus 142.8 minus 27, which makes this angle 10.2 degrees. Now, I also misspoke earlier when I said whenever you do the law of sines and there's two triangles, one triangle is going to be obtuse, the other one's going to be acute. All right, that was a lie because right now we have two obtuse triangles, which is possible. What I should have said is that in one triangle, like the first angle that you find is going to be acute, and then the corresponding angle is going to be supplementary to it. So which means that one has to be obtuse. But this angle could come out to be obtuse or acute. So if you get two obtuse triangles, you didn't do anything wrong. All right, and then we would just finish this by finding side A by doing a law of sines. Like do the sine of 115.8 over A is equal to the sine of 27 over 303. All right, and then cross multiply that. So I'll just type that in my calculator. I'm going to do 303 times the sine of 115.8 is equal to A times the sine of 27. So then divide both sides by the sine of 27, and you get 600.886. So now we got in this triangle, we found this angle and this angle and this side. And in this triangle, we found this angle, and now to find the third side, we would do the sine of 27 over 303 is equal to the sine of 10.2 over A prime, which is going to be shorter than A. Cross multiply, and the sine of 10.2 times 303 is equal to the sine of 27 times A. So then divide that by the sine of 27. And we get 118.2 meters. Okay. So in both these triangles, they both have a given angle that's 27 degrees. They both have an adjacent side that's 404, and they both have an opposite side that's 303, which is why this is called the ambiguous case. It's not clear that there's only one triangle. There's two triangles that can have that, and we just solve for both of them. And we just use the law of sines. So the two main steps here is knowing that there are two triangles. If you could figure that out, I would think the only other new thing you have to know from that adds on to the law of sines, because everything else is just law of sines, is when you find that first angle, know that in your second triangle, that same angle with the same letter is going to be supplementary to it. Because if you look at these two triangles drawn on top of each other like this, all right, when we do law of sines, we get this angle's 37 first, which means this angle's 37 because it's an isosceles triangle, which means that this angle B in this obtuse triangle has to be supplementary to it because it's formed a linear pair with that angle. Okay? Any questions? It's really hard to teach when I don't see anyone. It would happen, so if so when is there one triangle? If the angle is obtuse, and this side here is more than that side, so when it's an obtuse triangle and the opposite side is more than the adjacent side, there'll be only one triangle. Well, if the side opposite the angle you're given is ever more than the side adjacent, then there's always going to be one triangle exactly. If the side opposite is less than the side adjacent, it depends on where the angle is acute or obtuse. So yeah, if the side opposite is less than the side adjacent, then this would be one triangle, this would be, and then if it's an acute angle and the side opposite is less than the side adjacent, then you have to find the height. And if the height is bigger than 9, then there'd be no triangles, because then this won't reach. Like if the height came out to be like 9.5, this side won't reach the other side. If the height was equal, then it would reach at exactly 1 point and create one right triangle. And if the height was less, then that's when you have your 2 triangles. All right, and that's pretty much all of it. And it's all summarized in the notes we did yesterday, but also I posted something here which kind of walks you through it. So when you're thinking about it, all right, first, if you're given one angle and 2 sides, check for the ambiguous case. And it should say given one angle and 2 sides where the angle is not in between those 2 sides, because then if it's side angle side, we do something else. If the angle is acute, then that's when you have to compare the opposite side to the height. If it's obtuse, then you don't have to find the height. All right, so let's see. I'm going to end this recording and reassess the situation. Stop recording.